Hello again, everybody, and welcome to the RockWorks15 webinar. My name's Tom Bresnahan. I'm here at Rockware, and I'll be giving the presentation. With me today is Molly Mayfield in our office, and she'll be handling the chat box. So, Molly, if you could type in my name in the chat box. I have to spell it quite often, so it'll be better if you see it in front of you. But thank you for coming, and our topic for today is going to be RockWorks15 lithology modeling. So I've got our outline on the screen. Let's get rid of the clock and some of our notes here and clean up our screen a little bit. Here's what we'll be talking about today. We're going to start out with discussing the database structure of a lithology model. And then we're going to compare our lithology models with a stratigraphy model. Allison Alcott last month gave a talk on stratigraphy modeling. You can view that on our YouTube channel, which we'll have a link for at the end of the presentation. But you can just go to YouTube and search for Rockware software and find that as well. In addition, we'll be talking about the lithology model format and some of the algorithms that we have available for creating a lithology model. Then we'll talk a little bit about model visualization. We have solid cross-section and fence diagram views for your model, as well as some plan views. Then we'll end up with a discussion of how you can modify your models outside of the normal modeling regime. So you can combine a couple different models together. So let's move on to, here's our presentation outline. Let's start out with the database structure. What does the lithology data look like in RockWorks? So here's a slide that shows a portion of the RockWorks Borehole Manager screen, and you can see I've circled the Lithology tab here on the left side of the image. When you click on that, you get to see the following fields here for depth to top, depth to base, a keyword, and then any miscellaneous comments that you'd like to add for the description of your lithology. As you can see, it doesn't have to be a rock lithology, it could be soil, unconsolidated sands, or whatever you'd like to put in here. These keywords are taken from a table called the Lithology Types table. So when I click on that for icon, when I'm live in RockWorks, I'll show you that in a minute, but on this slide, let's move to the next slide. When you click on that, you get the Lithology Types table, which displays a list over here on the left of keywords that you can use. This example is similar to the one in the samples database. It's a pretty simple example, but we have 5, 6, 7 types of lithology. Each of those lithologies can be given a unique pattern and color. We do recommend you set the background color, because in 3D we don't display the patterns. Things would get a little bit busy if we did. So there's our patterns. The next column has a fill percent. If you were making a lithology column and you want to express the fact that clays might weather back or collapse into the borehole, you could reduce this fill percent so it only fill half the width or any percentage you specify. The next column has density values for converting volumetrics to mass, such as tonnage. But I've circled this column over here on the right. This is one of the more important columns, the G value for each of the lithology types. And this G value is a somewhat arbitrary numerical value that you can assign to your lithologies. But so they can be integers, they can be fractional numbers, decimal numbers. But I said somewhat arbitrary because they're not completely arbitrary. In this case, we've assigned gravel a value of 5.2 and sand a value of 5.0 to make it easier to group those two together when we're doing some filtering when we display our 3D model. So let's take a look at that in the RockWorks program. I'll show you let's bring the program over to the screen. And it's slightly different screen, so let's resize it. And so here we are. Here's when you start up RockWorks, you'll get a typical view as the one shown. The Borehole Manager tab is over here on the left. This is where we manage our boreholes. Here's our project folder where our database and most of our files will be kept. We recommend keeping them pretty much together. Here are our project dimensions with spacing. We'll be talking about that a little bit more. But as you can see, you'd probably start out with the location tab being selected. But here's where you would click on lithology. You can see this one, the comments are not listed, but we have a listing of different depths, depth to the top of the unit, depth to the base of the unit. And then here are our keywords. So you can just type in values here as you desire. Say this, we want to make a change and say this one's really 5.1 instead of 4.9. We can just type it here into the table, or we can import it from another source. Our keywords are over here in this column. If we click on it, we eventually get a drop-down list. Here's a list of all those keywords that we saw previously in the lithology types table. And when I click on it, you can see it pops up. Here's where we can define our pattern colors, background colors, and this is where we would recommend assigning a background color so it'll show up as a unique color in 3D. And then here are our G values. If I click on the heading here, I've got them sorted by numerical value. You can see we've grouped sand and gravel together here. If you import your data and don't assign it a unique G value, the program will give it all a value of 1, and so it won't differentiate between your different keywords. So this is an important step when working with lithology. Let's OK out of that. Okay, let's go back to the presentation, the PowerPoint slides, and let's start talking a little bit about some of the differences between lithology and stratigraphy models. Here I've got two cross sections on the screen. The lithology one's on the top, with the stratigraphy's on the bottom. You can see they look quite different. The lithology data do represent downhole rock or material types that aren't in a specific order. So you can have repeated entries. So sand, clay, we've got listed here. We can repeat our units, not a problem. If we have sand on top, sand on the bottom, this is what lithology is meant to represent. Whereas in stratigraphy, we take a look at that. We have these relatively smooth surfaces defining our stratigraphic units, and these are ordered units. So this yellow, this brownish color one is at the top, this thin unit, A horizon. Then we have the yellow unit is second, this light blue unit is third, the dark blue unit is fourth, and the dark brown unit is fourth, dark blue is fifth. So they have a specific order that is maintained. And this RockWorks uses that order when it's calculating the stratigraphy model. So it's important to assign that order. Let's take a look at what are some of the other differences of the model in 3 dimensions. So lithology, we're going to be modeling lithology with voxels or 3D pixels, and this can give the display a little bit of a blocky unit, but the reason for that is we're using little bitty blocks to model the lithology. A stratigraphy model uses stacked 2D grids. Let's take another look at the models. Here I've broken out a representation of the model. You can see we're using these little blocks here. Each of those blocks is assigned a numerical value and a color, and that numerical value is that G value that we were talking about earlier. And so each of these colors or values is a function of its X, Y, and Z location in the model. In contrast, let's look at stratigraphy. I've overlaid a kind of a coarse-looking grid here on top. The actual grids are actually more detailed here, but this will, I'm trying to hammer home the point that stratigraphy uses a series of stacked 2D grids. So we're actually modeling the elevation of each of the units as a function of only its X and Y location. So XY for stratigraphy, XYZ for lithology. So when we actually display it in 3D, we can turn on the sides here and give it a solid look to the model, but it's actually only composed of 2D grids. Okay, let's move on to how do we actually create a model for lithology. And so I'm going to talk about two of our two lithology interpolation options, the algorithms that we use to calculate what is going on between the boreholes. So here I've got a cross-section with 4 boreholes, and I have various units, pink, blue, green, yellow, etc. So we have these two interpolation options. One we call lithoblending, and this one has a very strong horizontal weighting component to it. And then the other one is called closest point with no directional weighting. So what do I mean about this? In both cases, if we're at one of these voxels here in between our two wells, the program looks for the nearest borehole and assigns a color based on that nearest borehole when we have boreholes on either side of the voxel. So let's move on a little bit. You can see in this case here, these voxels here were closest to this drill hole 17 with a green unit, so they're assigned a green color. These other two over here are closer to this drill hole 39 with the pink unit. They're assigned a pink color. So we just go in, I've just colored in more of the model to show you what's going on here. If we have pink units on either side of the voxel, then we get a continuous representation of the unit. If we have different colors between the two boreholes, we get differing colors. So where some of the changes occur are down below total depth, where you might only have control for one borehole if you're using the lithoblending method. This horizontal weighting actually says that, well, even though this borehole is closer vertically, this horizontal weighting will actually pick up a color from a borehole that's further away. And this is good if you have horizontal units with this horizontal weighting kind of honors that horizontality to this structure. Whereas if we were using a closest point algorithm, we're right here below total depth of drill hole 17, but the pink one's closer, so we're going to assign it a pink color. Now, some of our lithology models need to honor this if we have a vertical stock or some kind of a vertical unit that we don't want to have the horizontal weighting apply, then closest point is a good method to use for that type of a model. So what are some of the options that we have when we're modeling? If we're using lithoblending, you can see we get a pretty blocky unit within this yellow rectangle. We get abrupt changes from one unit to the other. Over here, pink, green, it's a very abrupt change and it's very vertical. If we turn on this randomized blending method, we can introduce some interfingering or feathering between the two units in the middle third area between these two boreholes. Same over here where the more complicated lithology, we get some interfingering going on. Because it is a random type of a choice, in the middle here it can go either way, either green or pink. If you recreate this cross-section, we'll get a different look to this feathering. So it's not a, we don't reproduce the same feathering with each run because it's kind of a random choice. Let's go on to some of the other modeling options that we have to improve our model. Certainly, we can use a thinner spacing to reduce some of the blockiness, and you can see in between these two boreholes here, we're getting some thinner feathering or interfingering between the orange and the yellow units. Another thing we can do to modify the model when we're creating it is to introduce a constant dip to the entire model. And so this one, it does a very good job of modeling this angled contact here at 30 degrees in the north 135 east direction, which is the trace of this cross-section. A third thing that we can do to vary the model is to warp it based on a surface. So in this case, I've introduced a gridded surface that defines a surface that I want the contacts to conform to, and you can see a little bit of bending going on here to match that surface. This would be a good thing to use if we've got some post-depositional deformation, maybe some structural deformation after the units are lithified. So if you've got a lot of bends to the contacts, then warping is a good choice. Let's go on then to talk about some of the, well, before we go on to model visualization, I think I will try to squeeze in a little bit of a view of the actual RockWorks program to see where this is all taking place. And the modeling occurs from this lithology menu here at the top. So we go down to lithology. If we choose to make a model or any of these other visualization methods, we will get the option to create a new model or use an existing model. So you can see in my existing model box, I've already created one with tilting and directionality that I put into the model name. But typically you're starting out and you're creating a new model. So down here, our model dimensions are important. Remember, if we want those thin units to be interfingering here, then we want a pretty thin spacing in the Z direction. Let's go down here and look at the algorithm. Here's our two choices, litho blending and closest point. And then if we expand that out, you can see we have options to randomize the blending, also to interpolate outliers, which means to completely fill that rectangular solid of the model or have it cut off where you don't have any data. In addition, you'll see some of my models that will be coming up later. We have the option to automatically truncate the model with upper and lower surfaces. Automatically, we can do an automatic truncation based on our borehole collar elevations. This is good because we very seldom have lithologies that occur above the ground. So this is an option I often have turned on. In addition, I can turn on a lower surface, either one I specify manually, or I can automatically truncate it based on the total depths of my boreholes. So this will be good if I don't want that interpolation to be going on below the boreholes. Okay, let's go back to the outline and talk a little bit about some of the model visualization. Here's some examples. You've probably seen them before, but let's just these are some of the ones I'm going to talk about. We have three-dimensional models like this rectangular solid here that show our lithologies in different colors. We have profiles and cross-sections with an example shown down here at the bottom with the boreholes listed. We have fence diagrams, which are just showing our profiles in 3 dimensions. And we have some plan and surface maps that we can take a slice through our 3D model, either on a horizontal plane or through a gridded surface. Let's start out with lithology profiles. Here's a different example that I have here on the left, and you can see I've truncated my model based on total depths of the boreholes as well as the ground elevations. You can see a faint red line here representing the actual gridded surface. So I think this is good, or otherwise our model would extend all the way up to the top of this white rectangle here. We don't want our lithologies above the ground, so it's a good idea to truncate them. When we're making a profile, profile is defined by a single straight line segment that has a starting and an ending point, and it has what we call a swath. And this is represented by this yellow rectangle drawn around the trace of the profile, and this defines how far in should we grab wells to place on the profile. So these wells are within the yellow rectangle, they're all included. These boreholes, drill hole 41 is outside the rectangle. It does not appear on this profile. Profile, since it's a single plane, we can use it to project our non-vertical boreholes into the plane of profile. We can't do that with a cross-section because we don't know what that plane of profile may be at any given point. Let's move on to the lithology cross sections. You can see in this case I've got a wildly zigzagging trace of my cross section. It's tied to each of these boreholes that I clicked on along this trace. So I purposely did not click on drill hole 17. Perhaps there was no data, or there was something about the data that I didn't like. Maybe it was logged by a different logger, so I chose to omit it from the cross-section, and you can see that there is some effect from that borehole here in the model, but it's not shown. Let's move back here. I've managed to move ahead a little bit. So that borehole that I skipped does not appear on my cross-section, and only vertical boreholes will be shown. So even my deviated boreholes that are deviated from vertical, they would be displayed as vertical on a cross-section, because it's very uncertain how you would, what would I do with this borehole here, project it to this panel or this one. We decided not to address that question and only use the boreholes that are along the trace of the cross-section. Another example that we have for displaying our lithology models is this fence diagram. And I've put it into motion here so that you can show some of the three-dimensionality, or see some of the three-dimensionality of the model. I'm just rotating it through 45 degrees and looping it through. I've got panels along the edges of the model. I've got panels through my model. I can define where all those panels are located, and I can set some of the transparency or opacity of the panels, so I can look through and see the boreholes on the model. Let's move on to another type of visualization for our lithology models. These are the plan maps and the surface maps. Both of them will produce a similar looking 2D map of the lithologies that are encountered. For the plan map, we're truncating or slicing through the model along this orange plane. For the surface map, we're actually cutting through the model along this varying gridded surface. It's in blue here. Both of those will produce a 2D map, and you can see sort of perhaps a subcrop map or some other type of map of what lithologies you can expect at that level. That might be good if you're planning to dig a pit and mine some near-surface aggregates, for instance. Okay, let's talk about what can we do with this model. One of the things we can do is calculate the volumes of the different units that we have in our model. Whenever you produce a 3D visualization, a piece of which I've included over here to the right, you'll get this panel to the left that lists all the items in 3D. And one of the items that's included, that you can include optionally with the model, is a calculation of all the volumetrics for each of the units. So for the clay unit, we have a volume of about 31 million cubic units. And what are those units? Those units are defined by what you've put into the project dimensions and your boreholes. So we strongly recommend that if you're looking at volumes, all those units should be the same. If the XY units are meters, the depth units should also be meters. If you want to work in feet for depth, then we recommend converting your XY units to feet as well. Over here we have a mass calculation. These mass numbers come from that density factor that we added on our lithology types table. So we just multiply that factor by the volume to get a mass listed here. In addition, when I double-click on the lithology model, I get the options for it, and some of the options down here are to filter out the model based on its G values of the units. And we've got them listed here. So sand was 5. Remember, gravel was 5.2. Remember, I said I wanted to group those together so that I could filter out all the other units. Well, here's where I'm doing it here. I've turned on the filter to enable it, and then I set a low filter of 5 and a high of 5.5. So I'm only showing those two units, gravel in orange and sand in yellow, on my model, and it also sums my volumes. So I have 95 million cubic meters here. You can see that just comes from adding up 54 million here, 41 million here. In addition, we have some other volumetric calculations you can get to from the RockWorks menu in the Borehole Manager. We can also calculate interval-based volumes where we actually specify the minimum and maximum level that we want to calculate volumes for, what are our labels going to be, and this just puts it out into a nice tabular format that we can export to Excel or another spreadsheet. Okay, we've got a few minutes left. Let's talk about how we can modify our models. Here I'm showing two different models. The top model is our typical lithology model. You can see that strong horizontal component. I've used lithoblending to model this lithology section, and I've truncated it based on an upper and lower surface. In this lower diagram, though, I'm saying that I've got a totally different regime going on down here where I have an unconformity, constantly dipping units at a 30 degrees to the southeast here, and I want to somehow combine these two models that incorporate these red units in the lower section with my lithology in the upper section. And the way we do that is I go to the utilities portion of RockWorks, and I just choose, we have a number of tools to combine models. Under the solid math menu, I can just merge the models based on this unconformity surface. So here's my upper model, here's my lower model, here's the dividing surface, and you can see I've combined the two models into one here. In the program, let's jump over to RockWorks. I'll show you more clearly where that is. Let's turn off my lithology modeling menu here. Remember, we talked about the Borehole Manager tab on the left. Here's our Utilities tab, and here is the solid menu. I can go down to Math, and here's where I can merge the two models together. I think I've done a pretty good job of keeping on schedule here. It's 10:29. We have a minute or so left for questions. You're welcome to type them in. I see somebody's been asking about faults already. We can address that later as well. Are there any other questions that anybody would like to present at this time? I think that's it then. Thank you all for coming. We've recorded this presentation, so we'll be posting it on YouTube. These long presentations take a while to render, so it'll be a few days, but we'll be happy to send you all links to the presentation so you can watch it again. But thank you very much. Oh, we have a question about user-defined digitizing. Yes, we can do digitizing on the 3D model. Let me bring one up real quick. Let's go over here. Let's see if I have anything in here under 3D. Let's see. Let's try this one here. So here we have a display of a 3D model. We can go into the digitize menu. Here's the icon here under digitize points. We can actually digitize in 3D right off the model. So I'll click here, and you can see that with every click I have to do a redraw, unfortunately. Maybe I'll turn that off for now. But whenever I click on the model, the XYZ location of the point I've clicked on. I think that you could use this digitizing maybe to put in a digitized surface, but yes, obviously the geologist is the expert. I'm a geologist. The computer is not a geologist. So this is one way you could digitize extra points for any purpose. We have a question, can we find the location of the maximum thickness in a model? Yes, we have a menu for that. Let's see if we can get out of this digitizing here. I'll turn it off here. No, I'm not going to save that. But under lithology, I'm thinking there is a way to extract the thickness of a lithology. And I think that would possibly be in this isopack menu.
total thickness of a specific
Mm-hmm.
if they want to find, what was the question, the max thickness?
So I think this would be a good way to get the max thickness. We'll create a sand isopack here, then we'd have the bullseye here where it was thickest.
Yeah, yeah. There might be another one too, actually.
So we have another question here. Okay. Let's see if pardon me if I've missed some of the previous discussion in the chat box. I just can't read it and talk at the same time, but here we are. You're talking about digitizing your correlations of lithology from borehole to borehole. You can do that in 2D, and what I would suggest is going into strip logs and making a section between boreholes. We could draw in our correlation there. Okay, good. Yeah. So let's just go here. I'll just make a quick little cross section here. If we don't like the model, the way the model came out with our initial parameters, we can certainly go in with our digitizing tools, draw a polygon, and say, yes, I want to connect these guys here. And I can then, after I'm done, I can click on it and fill it in with a pattern or color here. In addition, we do have a lithology picker. Under the lithology menu, we can pick the intervals in, let's see what we've got here. We've got lithology turned on. Let's just process this real quick. So that here we can go in and say, oh, I want to pick where my clay units are, perhaps not from a lithology log, but maybe a gamma ray and neutron log or neutron density logs. We could display these over here as well, but then I can say, where is my clay unit? I can just click here on the borehole, and it would fill in my pick from that borehole, and then save that if I so choose to the borehole database. I think that's all I've got for now. Yeah, and Molly adds that there's stratigraphy pickers as well. But thank you again for coming. We appreciate your attendance. And if you have any further questions, let me go to those links that I promised I'd show you at the end. We have you can go to our RockWorks page at rockware.com. Here's our YouTube link, youtube.com/RockWareSoftware. And then, of course, you can always send your questions via email to tech@rockware.com or sales@rockware.com. Thank you again, and everybody have a good day.